Welcome to this class. In this session, we introduce the concept of congruence of integers. We start by defining what we mean by an integer dividing another integer. So definition, we want to define divide. So an integer A is said to divide another integer B if there exists another integer K such that B is given by K A, and we write A divide B. So this vertical line is read as divide. So this is divide notation. So e.g., 2 divide 8, since 8 can be written as 4 times 2. Or we can say 3 divide 9, since 9 is the same as 3 times 3. Or we can say 10 divides 50, since 50 is the same as 5 times 10. Or we can say 2 divides 18, since 18 is equals to 9 times 2. I can say 11 divides 121, since 121 is 11 times 11. And say 7 divides 35, since 35 can be written as 5 times 7, etc. And then the opposite, if A and B are integers such that there is no integer K for which B equals to Ka, then we say that A does not divide B, and we write A, but then we cross in this what we write. So this means A does not divide B. E.g., you can say 2 does not divide 5, since no integer K exists such that 5 equals to 2K or K2. Yes, you get a value of K, but that K is not an integer. divide, the condition is that k must be an integer. Can say 3 does not divide 8 since no k exists, no integer k exists for which 8 equals to 3k, etc. So that's how we define the divide operation. Now let's define what we mean by linear congruence. So a congruence of the form A is congruent to B modulo M, where M is a positive integer A and B are integers, and X, so there's an AX, and X is a variable, is called a linear congruence. Now let's define what we mean by two integers being congruent. So definition. So let A and B be any integers, and let M be a positive integer. We say that A is congruent to B modulo M if M divides the difference A minus B, and we write so that's what we write. Or sometimes you can write it as A, then you put in brackets modulo M. So this is the definition. The statement is read as A is congruent to B modulo M, read as A is congruent to B modulo M. So that's the definition. So by this definition, it means that A congruent to B modulo M implies M divides A minus B. Or other definition, you're saying that A is congruent to B modulo M if M divides A minus B. So these two statements have the same meaning. And because we have already also defined what divide means, then this also means that there exists an integer k such that A minus B is equals to Km. This is still the same meaning of saying that M divides A minus B. So examples. So examples of congruence modulo. So you can say 15 is congruent to 1 modulo 7. Since 7 divides 15 minus 1. You know that 15 minus 1 is 14. So 7 divides the integer 14. And then number 2, we can say 8 is congruent to 2 modulo 3. Since 3 divides 8 minus 2, i.e. 3 divides 6. Number 3, we can say 40 is congruent to 7 modulo 11. Since 11 divides 40 minus 7. And you see 40 minus 7 is 33. So 11 divides 33. And then number 4, we can say 10 is congruent to 0 modulo 5, since 5 divides 10 minus 0, i.e. 5 divides 10. And number 5, we can say minus 7 is congruent to 17 modulo 8, since 8 divides minus 7 minus 17. We know that minus 7 minus 17 is minus 24. So 8 divides minus 24, etc. So if the opposite of being congruent modulo, if we can say A is said not to be A is said not to be congruent to B modulo M if M does not divide A minus B, and we write A then we negate by crossing it. So this read as A is not congruent to B modulo M. We can give examples. For example, we can say 15 is not congruent to 1 modulo 6, since 6 does not divide 15 minus 1. You see 15 minus 1 is 14, so 6 does not divide 14. So remember, when you are saying does not divide, you negate this vertical line. Another example, we can say 8 is not congruent to 2 modulo 4, since 4 does not divide 8 minus 2. You see 8 minus 2 is 6. 4 does not divide 6. And 3, we can say 40 is not congruent to 7 modulo 5, since 5 does not divide 40 minus 7. You see 40 minus 7 is 33. 33 is not divisible by 5. Another example, we can say 10 is not congruent to 0 modulo 9, since 9 does not divide 10 minus 0. See, 9 does not divide 10. And number 5, we can say minus 7 is not congruent modulo 17. Is not congruent. Minus 7 is not congruent to 17 modulo 9, since 9 does not divide minus 7 minus 17. You see 9 does not divide minus 24. And you can give as many examples as you like. Thank you.